In this lab, we have 5 routers that exist in 3 areas. Router 1 and fast Ethernet interfaces of router 2 and fast Ethernet interfaces of router 3 exist in area 0, which is the backbone area. Router 4 and the serial interface of router 2 exist in area 4. Router 5 and serial interface of router 3 exist in area 5. Our target in this example is to make all the routers know about all the networks using OSPF configuration. Before any configuration, every router knows only about its direct connected networks. So we will use OSPF routing configuration to make all the routers know about all the networks. First we enter to router 1 and enter to global configuration mode, then router mode, router OSPF, then process number, it is a locally significant number, let's take 1, enter, then network. First network is 10.0.12.0/24, 10.0.12.0/24 means that the subnet mask is 255.255.255.0. It means that the wildcard mask is to take the subnet mask and change every 1 to 0 and change every 0 to 1. So the wildcard mask will be 0.0.0.255, 0.0.0.255, then area number, and area number is this network exists in area 0, then network, the other network is 10.0.13.0, 10.0.13.0. the wildcard subnet mask is 0.0.0.255 and area 0. So we finished router 1. Now we enter to router 2, privilege mode, global configuration mode, router mode, router OSPF, then process number, let's take 1. Okay, then configure the networks. First network 10.0.12.0, network 10.0.12.0, the wildcard mask is 0.0.0.255, area 0, then network 10.0.23.0, .0.23.0, the wildcard mask 0.0.0.255, area 0. Then network 20.0.24.0, network 20.0.24.0, and the subnet mask is /30. This means that the wildcard subnet mask is 0.0.0.3, 0.0.0.3, area. This network exists in area 4. So now we finished router 2 configuration. Now let's enter to router 3, privileged mode, global configuration mode, router OSPF 1. Okay, router 3 is connected to 3 networks, 10.0.13.0 network, 10.0.13.0, 0.0.0.255, area 0, and 23, and the same wildcard mask in area 0. Okay, good. And network 30.0.35.0, 30.0.35.0, and the wildcard mask 0.0.0/30. This means that the wildcard mask is 0.0.0.3, area. This network exists in area 5. We finished router 3. Now enter to router 4, privileged mode, global configuration mode. Router 4 only connects to one network, 20.0.24.0/30, network router OSPF1 network 20.0.24.0.0.0.3 area number is 4, area 4. And also router 5, which connects only to one networks, also privileged mode, global configuration mode, router OSPF 1 network 30.0.35.0 30.0.35.0 wildcard mask 0.0.0.3 area 5. Now we finished the OSPF configuration on all the routers. Now we want to log into sample routers and see the routing table to ensure that all routers know about all networks. So let's first log into router 1. Let's write show IP route to see the routing table. Now see that router 1 is directly connected to two networks, 10.0.12.0 and 10.0.13.0. Those are the networks that are directly connected to router 1. The other networks, 20.0.24.0, this network, now router 1 knows about this network, and also 10.0.23.0, this network, router 1 now knows about this network, and network 30.0.35.0, which is this network. Now router 1 knows about its directly connected networks and this network and this network and this network. This means that router 1 knows about all the networks. C means directly connected networks. O means OSPF network. This means that router 1 knows about this network using OSPF routing protocol. IA means inter-area networking. Inter-area means that this network exists in a different area than this router exists. 20.0.24.0 exists in area 4, while router 1 exists in area 0. So this network, router 1 knows about OSPF routing using inter-area routing. Let's also enter to router 4 and show IP route. Let's see the routing table. Router 4 is only connected to one network, which is 20.0.24.0, which is directly connected to router 4. Now router 4 knows about all other networks. Router 4 knows about 10.0.12.0, which is this network, 10.0.13.0, which is this network, 10.0.23.0, which is this network, 30.0.35.0, which is this network. So now router 4 knows about all the networks. So now we ensure that router 1 and router 4 know about all the networks, which is the required target of our example.